Okay, this is a short example of a video that you might make for your project. Let's say that your topic is balancing equations. Well, you would have some examples in mind to write out and explain. One example that I've chosen is the reaction of hydrogen and oxygen to form water. Once you write your subscripts correctly, the only thing that you can do is change your coefficients. Hydrogen has a 2 here because it's diatomic. Oxygen has a 2 because it's diatomic. And the formula for water is H2O because hydrogen is a positive 1, oxygen is a negative 2. So you would crisscross that, so that would be your correct formula. And once you get your formula written correctly, again, all you can do is adjust your coefficients. So we'll start by looking at the hydrogen. There's 2 hydrogens on the left and 2 hydrogens on the right, so that's balanced. There's 2 oxygens on the left, but there's only 1 oxygen on the right, so we're going to put a 2 out front. So that's going to make our 2 oxygens, but it also makes 4 hydrogens. So 2 times 2 is 4 hydrogens, and we've got to come back over here and make sure it's balanced on the left, and that would be easy just by putting a 2 out front. So 2 times 2 is 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, 2 oxygens on the right. The equation now obeys the law of conservation of mass. We don't create or destroy anything in a chemical reaction. Now, with a short little example like that, you'll want to provide subsequent examples. Perhaps you would start with an easy one like this and progress to harder and harder examples. Now, I'll do another one. This is going to be kind of easy, but we'll still work it out just to show you that you're going to need to make sure that you provide multiple examples depending on the complexity of your topic. Here we have potassium chlorate decomposing to form potassium chloride and oxygen. Once again, oxygen has a 2 written beside it because it's diatomic. The potassium chloride, this is positive 1, this is negative 1, so it's written correctly, KCl. This one is a positive 1, and chlorate is a negative 1, so it's written correctly. Now, once all of our subscripts are written correctly, all we can do is adjust our coefficients. Now, we always want to save our oxygens for last, but in this situation, we can go ahead and start with them because it is very evident that the potassium and the chloride are both balanced. So we're going to go straight to our oxygens. So we have a 3 and a 2, and so we want to be thinking the lowest number that they'll both go into would be 6. So we'd put a 3 out front. 3 times 2 is 6. And we'd come over here and make sure on the left we have it balanced. We'll put a 2 out front. So 2 times 3 is 6 oxygens. Now our oxygens are balanced on the left versus the right, but our potassium and our chloride are now out of balance. So on the left we have 2 potassiums and 2 chlorides. But that's easy to fix. We just put a 2 out front here. So now our equation obeys the law of conservation of mass. Now, again, if you have a very complex topic, you may only have one example to work out. You may choose to type out the question on top and then work out the example, underneath it. Or, like I said, if you have a simple, easy to demonstrate problem such as converting grams to moles or moles to grams or adding up molar mass, you would certainly want to provide several examples. But once you get your video done and you are satisfied with it, then you're going to want to email it to me via my school email address, and it's on the board and on the school website and all over the place. But it is jeff.barron@harrelson.k12.ga.us. And you're going to want to email that to me, as well as your PowerPoint file and any Word documents that you have associated with it. And I'll, if you email those at different times, I'll put them together in one file to be graded. So you can certainly turn them in at different times, just as long as you in your email subject line and in the file name you make sure that you put your name and any kind of identifying information that I would need to sort it out. Okay. All right. Well, good luck. Hope it goes well, and I hope you enjoy reviewing the information and making a little short video. Hopefully it'll be good enough that we can then put it on our class website and other students can use it to review, as well as you getting a good review out of it. So like I said, good luck, and I hope it goes well.